Hello everyone, this is Muhammad Wasim Anwar and I am going to present you the research work titled Vehicular Architecture Blended Modeling in eSTDL. So the outline of this presentation is in first section I will discuss the background of this study. Then in second section I will discuss the proposed blended modeling framework. And finally, I will present two proof of concept demos. First one deals with the blended modeling of eSTDL timing constraints, and second one is about the software product lines. So eSTDL was introduced to support the model-driven development of automotive embedded systems. eSTDL meta model is based on four abstraction layers as shown here. First one is vehicle level, then analysis level, then design level, and finally implementation level. If we look into the domain model of the eSTDL, you can see there are different packages available for the modeling, like structure, environment, behavior, variability, and so on. So the definition of these packages and their relationship with the other packages are well defined in the eSTDL meta model and specifications. System model is the top level container of the eSTDL model. It basically contains the system and its concepts related with the different level of abstraction like vehicle level, analysis level, design level. So based on eSTDL meta model, different modeling tools have been developed. For example, EATA, Robust, and so on. So interoperability between tools is achieved through the eXML format. Basically, it is the representation of eSTDL modeling elements in XML, and it conforms to the standard XML schema of eSTDL. Existing eSTDL tools support graphical modeling, but blended modeling environment supporting both graphical and textual notations is missing in existing eSTDL tools. So there is a need of a blended modeling environment that should support the text editor to facilitate modeling in programming language like syntax along with graphical notation of existing eSTDL tools. While achieving this, there are a few other requirements like text editor will typically operate on a subset of the model. For example, packages with data types or other elements may be imported from existing eSTDL tools and subsequently visible and part of the scope in text editor. Another requirement is that it should be possible to create models in the text editor that do not fully conform to eSTDL meta model to ensure rapid prototyping and evolution of content. It should be possible to split the information in one model into different files. The elements themselves can reside in separate files. So the order of elements in the eXML file should be preserved on deserialization. New elements should be added according to the order in the tree or textual representation on serialization. So to achieve these requirements, XText-based blended modeling environment is proposed here. On the right-hand side, you can see different eSTDL toolchain like EATOP, Robust, etc. So the system model can be developed using different eSTDL packages like vehicle level packages, analysis level, design level, requirements, and so on. So this system model is eventually available in eXML format. In the proposed framework, the first step is to specify the XText grammar for eSTDL packages of choice. It can be timing, variability, requirement, and so on. So it depends on the requirements. So based on this XText grammar, text editor is available to perform the modeling in programming language like syntax. So there are two more components in the proposed framework. First one is the eXML parser and merger. So eXML parser basically feeds the information about the system packages and elements as defined in the eSTDL tool and then display it in the text editor. So the system packages elements are accessible in the text editor. So in this way, user can use these elements to model the requirement in text editor. Another component is transformer. It has two purposes. First one, it is able to perform it is able to generate the target models to perform the V and V activities. And the second purpose of this transformer is to generate the eXML of the instance model that is created in the text editor. And this eXML is then merged back into the main eXML, and finally the changes are propagated back to the existing eStadL tool. So this is the overall flow of the proposed XText-based blended modeling environment. So let's move to the first proof of concept, that is about the blended modeling of eStadL timing constraints. Here we have used the EA-top to model the Viper case study design without any information about the timing constraints. So this system design of Viper case study is eventually available in eXML format. So in the proposed framework, we first define the XText grammar for eStadL timing constraints. And based on this XText grammar, text editor is available to model the requirements in programming alike syntax. So as already discussed, the eXML parser fetch the information about the Viper design elements from the EA-top, and then these elements are accessible in the text editor. And here transformer will transform the instance model in text editor in eXML format, and then it is merged back into the main eXML, and finally the changes are propagated back to the EA-top. So in this way, we achieve the blended modeling. So this is the snapshot of the timing package of eStadL. Here you can see that different timing constraints are available. Particularly, there are 10 timing constraints, and there are different concepts like event functions, event change, and so on. So we will gather all these concepts in the XText grammar. So let's move to the demo. So this is the eXML file that is developed in the EA-top to that contains the design of the Viper case study. So let me import it in the EA-top. Here you can see the different design function prototypes are available. But here you can see there is no timing related information available. So it only contains the design elements of the Viper case study. Now we will get all these design elements in the text editor. So this is the XText grammar we have developed for eStadL timing constraints. Here you can see different concepts of eStadL timing constraints are available, like constraints, event chain, event function, and so on, and different constraints are also available. In this file, we will fetch the information about the design elements and display it in the text editor. You can see this is the path of the file that we have just imported here. So and so basically the transformer is implemented in Xtech, so it is capable to generate the equivalent EXML at runtime. So as users specify the requirements in text editor, the equivalent EXML will be generated accordingly. So these are the rules that we have implemented to generate the EXML file. So let's move to the editor. Here you can see that different packages are available and user can specify the requirements as per the needs. And now here you can see these design elements information is available. On the control space, you can see all the design elements as defined in the EA top. Let me show you. So these are the design function prototypes, and then this is available in the textual editor. So user can select the design element as per the requirements during the modeling in the text editor. Similarly, different context assistance is provided in the editor so that user can, for example, in control space, so user can define the constraints in the scope, and if we put the cursor there, then user can define different constraints. So the context assistance is provided to the user. So let's integrate it into the main EXML file. Again, you can see there is no timing related information available, but in the text editor, we define few constraints like periodic constraints, few event functions. And now, before we move forward, let's see the timing. So this is the timing EXML that is generated at the runtime. So here the timing package basically reside on the separate file. Now we are going to integrate this timing file into the main file. Here we have implemented the here you can see this is the main file and this is the path of the timing file. So let's perform the integration. So now you can see that this file is now successfully updated, and if we refresh this, yes, now here you can see that the timing package is available here in EA top, and it can be used here. So we defined basically all the constraints in the text editor, and now it is available in the EA top. So let's create an event function here. Let's name it it. So we have created another event function here in the EA top with the name blended, and you will see that this is immediately available in the text editor to perform the model. Here, sorry, I forgot to save this. Yes, I am now saved this blended, and now you will see that it is uh, available in the text editor as well. So in this way, we will achieve the blended modeling. The elements defined in the EA top are available in the text editor, and the things we are going to model in the text editor are also available in the EA top. And importantly, it is not necessary that it is only compliant with the EA top. I mean, it is basically operating on EXML. So any other tool like Robos are okay. I mean, we can use these tools and the framework will work fine on all the existing ESTDL tools as far as they are compliant with the EXML format. So if we move to the requirements now. So the first requirement is the text editor to facilitate modeling in programming language alike syntax along with graphical notation of existing ESTDL tools. So here you can see that we are performing the blended modeling and all the information graphical elements are available here. So the first requirement is fulfilled. Now, second one is the text editor will typically operate on a subset of model. For example, packages with data types or may be imported from to and visible and part of scope. Here you can see the design function prototypes are available here. And if we look into some other, I mean, data types, let's see, data types. So different data types as defined in the EA top are also available here. If we can, here you can see the Boolean, integer, numeric, real, float. These are available here, and basically these data types are defined in the EA top. So the second requirement is also fulfilled. Now, third requirement is it should be possible to create models in the text editor that do not fully conform to the HTML model. So here, if we can see the meta model of this text grammar, so this is not compliant with the existing HTML timing meta model. I mean, there are changes. We are starting it from the file. But of course, we combined it with the existing ESTDL meta model through EXML format. I mean, here in the transformations, we achieve the compliance. This is the reason that the the element defined in the text editor are visible and usable in the EXML. In the EATOP, sorry. So because we have performed the compliance in the this transformation in EXML transformation. So in this way, we can extend the different, we can add different concepts in the XText grammar, and of course, these can be used in the modeling, and of course, these will be preserved in the textual editor. So we can create the model in text editor that do not fully compliant with the HTML meta model. So this requirement is also fulfilled. Now next is it should be possible to split the information in one model into different files. So if we look into the timing EXML, it is stored in the different EXML. And of course, both can be integrated and available in the EA top. So point is in this demo, the information is split into different EXML files. So the information in one model into different files. So this requirement is also fulfilled. And finally, the order of element in EXML file should be preserved on deserialization. Here you can see the serialization and deserialization is performed correctly. For example, the timing package is added and all the sequence of elements is preserved as per the definition in the text editor. So to conclude, all the requirements are fulfilled here. And now let's move to the second demo. So this demo basically deals with the blended modeling of software product lines. Here again, as we already discussed, we have used the EATOP, but in this case study, this is also the Viper case study, but we have three variants. We developed the system model that has three variants. One is automatic Viper, then rear Viper, and with stalks. So system model is available in EXML. Of course, in the proposed framework, we defined the Xtext grammar for variability. Basically, variability packages deal with the software product lines in each.dll, and based on this variability grammar, text editor is available. We already discussed this. And the information about the system model is fetched and then accessible in the text editor and the transformer. Here, transformer, we have a variability resolution algorithm that generates the variant based on the configuration decision or the configured features. And of course, the transformer will also generate the EXML that will be integrated back into the main EXML, and the changes are propagated back to EATOP. So this is a snapshot of the variability package of each.dll. Here different concepts are available like feature configuration, configuration decision, and there are other concepts. So we have tried to capture all these concepts in the Xtext grammar. So let's move to the demo here. So first of all, let's import the case study. Here we are now importing it in the second folder. So here you can see the configuration for different variants containing analysis function, design function, and so on is available here. So automatic Viper, rear Viper, and so on. And each variant has its own timing constraints associated with it. But here you can see we don't have the information about the variability. How the variability is not uh, defined here. So we will define the variability in the textual editor here. So if we open the so here we define the Xtext grammar. Here you can see the different the concepts related to the each.dll variabilities are available, like variability element, feature link, feature group, feature constraint, and so on, selection criteria. So based on this Xtext grammar, we have the text editor. So here you can see that we can define the variability in the text editor, and of course all the features in the system model defined in the EATOP are available here. Here you can see that different features are available. So these features are basically defined here and in the system model. So these features, so we are defining the variability by using the features. Those are defined in the EA top here. So let's, and if we look into the variability, so this is the EA XML file of variability. So let's integrate into the main. So variability information is currently not available here. And let's refresh it. Now you can see the variability information is integrated here and can be used here. You can see, and this variability, basically we have defined this here in text editor. So this is the first step that we have integrated the variability defined in the text editor into the EA top. Now we have also implemented an algorithm to resolve the variability and generate the variance. This is the file. Let's execute the variability algorithm. Here you can see that the algorithm generates 3 variants based on the configuration decisions. And the detailed description about how this variability resolution algorithm is working is out of scope in this demo because it will be discussed in the separate demo. So if we import it in the EA top, so here you can see the generated variants, only the relevant information is available, and in fact it can be used in the EA top. So in this way we achieve the blended modeling environment, and I mean all the requirements are fulfilled through this framework. So thanks for your time.